Good day, everyone. Our topic for today is all about t-test concerning means of independent samples. But before that, don't forget to like and subscribe to this channel and hit the bell button for more updates. Also, you will find different subjects in this YouTube channel. Just click the playlist section. And now let's proceed to our main topic for today, which is all about t-test concerning means of independent samples. Okay, let's have the definition first. T-test for independent samples. This is probably the most widely used statistical test of all time and certainly the most widely known. It is simple, straightforward, easy to use, and adaptable to a broad range of situations. No statistical toolbox should ever be without it. The formula to solve for the t-test for independent samples, we have x1 minus x2, which is the mean 1, sample mean 1, minus sample mean 2, over square root of the variance, which is s standard deviation squared over n sub 1 plus s sub 2 squared, which is the variance 2, or the standard deviation squared over n sub 2. So, where x is the sample mean, s is the standard deviation ko. So, pag may squared siya, that's variance. And n equals the sample size. By the way, we will use t-test if our given a sample size is less than 30. If it's greater than 30, we will use z-test. Okay, let's have problem 1. A course of chemistry was taught to 12 students using the traditional method. Another group of 15 students went through the same course using another method. So at the end of the semester, the same test was administered to each group. The 12 students under the method B got an average of 81 with standard deviation of 5, and the 15 students under the method A got an average of 85 with standard deviation of 9. Test the null hypothesis if there is a significant difference in the performance of the two groups of students at 5% level of significance. Um, by the way, in the t-test for independent samples, we always use the two-tailed as our tailed number of tailed, which is a non-directional um, which is a non-directional. Okay, so okay, let's proceed. So this is the problem, and first determine the hypothesis. Okay. Um, by the way, I have a separate video for determining the hypothesis. You can click the in the description box below the link. It is entitled "Easy Tips in Hypothesis Testing." Okay, so that you will know how to do hypothesis. But by the way, here to find the hypothesis, just look for the imperative o yung pautos. The imperative is test the null hypothesis if there is a significant difference in the performance of the two groups of students. So that's the imperative. Okay, so you can just eliminate this portion to make a statement. So the statement is there is a significant difference. So from the sentence there is a significant difference, meaning that this given statement or imperative is a alternative hypothesis. So our null hypothesis is there is no significant difference in the performance of the two groups of students, and there is a significant difference in the performance of the two groups of students. Okay, now after determining the hypothesis, we can have the critical value. Our alpha is obviously 5%, the level of significance, or 0.05 in a decimal form. Our tail is two-tailed, just like what I've said. Our n, total number of n, which is equal to 27. Why it's 27? We have 15 for the group of students and another is 12. So we have 27 in total. So we have n1, which is 15, and n2, which is 12. For the df, we have 25. So the formula for the df is n minus 2. Okay? So we have a formula for the df, n minus 2. Alright. This is only for independent, but in a dependent or the comparing sample mean and population mean, we will use n minus 1. And the critical value is 2.060. Okay, let's see if it is correct. So we have tailed, two-tailed, 0.05, 25 as our DF, and 2.06. So we will use the table. Alright. For the given table, we have two-tailed 0.05. Here it's 0.05, okay? So these are the numbers under 0.05, the area. And then we will look for the 25. Okay, 25. Here it is. So this is 25. And then where is that 0.05? Okay, this is. So the area, the intersection between 25 and 0.05, two-tailed, is 2.060. That will be our critical value. Okay, so did we get the same? Okay, correct. So we get the same answer for the critical value. Okay. All right. Now let's proceed to the given. For the given N1, we have 12. For the 12 students, which is method B, we have N2 for the method A, which is the 15 students. For the S1, we have 5. That will be 5 standard deviation for the 12 students and 9 for the 15 students. Okay. For the X1, that will be the 12 students, I think. They got 81 average. And for the X2, they got 85 average. Okay? So you just look for this here in the problem. So we have 12 students that got an average of 81 with a standard deviation of 5. So 12 students that got an average of 5. I mean, the average of 81, yeah. And standard deviation of 5. So same with 15 students. Now, we will use the formula and then substitute the given in the formula. Okay, you can just solve it on your calculator if you want. If you have a very good scientific calculator, you can just click all of this. If not, you can just click maybe one by one. So you can just start with 81 minus 85, then just write your answer, divide let's say 5 squared divide 12, just write your answer, plus 9 squared divide 15. Write first your answer and then add the two answers and then get the square root. Okay, just don't forget to write your answer in a 4 decimal places. Every solution should there be a 4 decimal places. If there is an answer that has too many decimals. Okay. Now, after answering that, just divide the negative 4 in the numerator. Tama ba? 81 minus 85 is negative 4 to your answer here. And you will get negative 1.46. For your final answer, you always use 2 decimal places. It's okay for you to use 2 decimal or maybe 3 decimal places. Pwede yung gayahin yung sa critical value so that you can compare the two. Okay? So we have negative 1.46. It's okay na sa akin, negative 1.46. Except if they have the same critical value for your answer. Okay. So let's compare now. This is our 2.060, the critical. Actually, it's positive negative 2.060, meaning to say this is the negative 2.060 and this is the positive 2.060. If nasa loob ang ating computed value, therefore we will accept HO. If lumagpas siya, we will accept HA. So this is our computed value. That's negative 1.46, right? So therefore, we will accept HO and reject HA. Then go back to the hypothesis that we wrote. What is HO? And the HO is there's no significant difference in the performance of the two groups of students. Meaning to say method A and method B might have the same effect with the learners. Okay? Now, let's have another problem. Problem 2. An agriculturist randomly selected 18 matured apple trees, of one variety and have a mean height of 12.4 feet and standard deviation of 1.30 feet. While 14 randomly selected apple trees of another variety have a mean height of 9.8 feet with standard deviation of 1.55 feet. Test whether the difference between the two sample means is significant. So let's see. Okay. So first, the imperative is test whether the difference between the two sample means is significant. So you can just, the difference between the two sample means is not significant, and the difference between the two sample means is significant. So I hope you already know how to do this. But then again, if you don't know how to do a hypothesis statement, you can just click the link in the description box below. And now, for the critical value, we have alpha 0.05. Actually, there's no alpha here. If there is no written alpha in the problem, you can already write 0.05. Okay? 0.05. There is no, since there you're just getting the, what do you call this? The, just the number of height. If it is medicine, that's 0.01. Okay? Kasi you only have 1% to commit mistake when it comes to, medicine. But in educational matter, you can use 0.05. Okay? So tailed is 2 and T is 32. Okay? We're talking about the total here. But individually, there are 14 and 18. Therefore, there are less than 30. So our DF is 30, which is n minus 2, and CV is 2.042. Let's see. In the critical table, we have 2-tailed 0.05, then 30. Again, it's 0.05, so hit dito siya. So let's look for 30. This is 30, right? And then let's see the... Okay, this is 0.05. So, tama ba? 2.042? 2.042? Okay, correct. 2.042. So that's the critical value here. Correct. So that is our critical value. Now, for the given, all right, we have n equals 18. For the 18 apple, we have, okay, 14 apple for the, for the other variety. Sa S1 ng 18 apple, we have 1.30. For the 14 apples, we have 1.55. For the mean of the 18 apples, we have 12.4. And for the mean of the 14 apples, we have 9.8. Now, let's compare if there's a significant difference between the two sample means of apples. So this is the formula, and this is our given written in the in the formula. So we have 12.4 minus 9.8. Just write your answer, then get the square root of this one below. So we have 1.30 squared over 18 plus 1.55 squared over 14, and then just add, and then just square root. Okay? So for the final answer, you will get 5.05. Okay, that's our final answer as I solve this given equation using my scientific calculator. Now, okay, let's compare now. This is our critical value, positive negative 2.042. So if inside the 2.042, that we will accept HO. If outside, accept HA. So unfortunately, our computed value is greater than 2.042. Therefore, we will accept HA and reject HO. Hence, the conclusion will be the difference between the two sample means is really significant. Okay, so there is a significant difference between the two sample means of the apple, of the variety of apples. Okay, so that's all about for the t-test concerning means of independent samples. With that, thank you very much for listening, and good day.